Pythagoras theorem. Pythagoras theorem is a topic that requires a bit of knowledge about a right-angled triangle. As we can see, a right-angled triangle always has a right angle, obviously, but this reveals a specific element linked to every right-angled triangle. I'm talking about this side of the triangle. This side has a name known as the hypotenuse. There are two ways to identify the hypotenuse. The first is that the longest side on any right-angled triangle is the hypotenuse. The second is that the hypotenuse is always opposite the right angle. Look at the following examples of right-angled triangles. As you can see, all these right-angled triangles, regardless of the size of their sides, have a side that is the longest. Once again, these sides are known as the hypotenuse. Now we understand that. How does this link to Pythagoras' theorem? Pythagoras' theorem is a formula that helps identify the lengths of one of the three sides of a right-angled triangle when the other two are known. This is the Pythagoras theorem formula. This formula relates back to why I went through the structure of a right-angled triangle. Each letter in the formula relates to the distance of one of the sides on a right-angled triangle. As we said previous, the longest side is the hypotenuse. The letter that represents the hypotenuse in this formula is always C. The other two sides are either A or B. So the formula tells us that if we square the distance A and add it to the square of distance B, the answer will be the distance C squared. There are instances where the hypotenuse can be found on various shapes such as the square and rectangle. If we draw a straight line from a corner on one of these shapes to the opposite corner, we would have split the shape into two right-angled triangles by a diagonal line. Since we have the dimensions for these shapes, we can easily find which values represent A, B, or C, and so can find out the hypotenuse. For example, if we had a right-angled triangle where distance AB is equal to 3 centimeters and distance BC is equal to 4 centimeters, what would distance AC equal to? What we do first is identify what distances we have in relation to the formula and what distances we don't. Going back to our right angle with the letters, we can see we have the known values for distances A and B, but no C distance for the hypotenuse. Next is to rearrange the formula to make C the subject. To do that, we square root both sides. This will leave the formula looking like this. Next, we plug in the values into the formula. We now have the square root of 3 squared plus 4 squared, which is equal to an unknown value of C. Next, we simplify the values inside the square root symbols, giving us square root of 9 plus 16, which equals to the square root of 25. As you have probably already figured out, to get the value of C, you just square root 25, giving us the answer 5. The final stage is to ensure you have the correct units. The final answer is 5 centimeters. Another example can be distance CD is equal to 7 millimeters and distance CE is equal to 10 millimeters. Find the distance of DE. Give your answer correct to 3 significant figures. Once again, we identify on the right angle triangle the distances we do and don't have in relation to the formula. In this case, the longest side is known, so C is equal to 10 millimeters. Our value for B is equal to 7 millimeters. The A value in this question is the unknown value. Since it's the A distance that is unknown, we now rearrange the formula to make A the subject. A A couple of extra steps are needed in comparison to the previous example, but don't worry, it's pretty straightforward. First, you move the b squared to the other side of the equal sign by subtracting it from both sides of the equation, leaving the formula like this. The last thing we do is square root both sides so that a is just by itself. Now we put in the values into the rearranged formula and simplify like before. To find the value, all we do now is square root 51 with our calculators. The value that is presented on your calculator should be this long decimal number. Now remember, the question asked to give the answer correct to 3 significant figures, so the final values are the first 3 numbers of the answer, which is 7.14 millimeters. Another example can be, the above rectangle has a height of 8 centimeters and a length of 17 centimeters. Calculate the diagonal distance from A to B. Give your answer correct to 3 significant figures. Just like how I explained it before, we can make 2 right-angled triangles by splitting the rectangle with a diagonal line. This reveals the different parts we need for the Pythagoras equation. Remember, the hypotenuse is the opposite side to the right angle, so C is unknown. The values of A and B are 8 and 17. Going through the same process to calculate C, the final answer is 18.8 centimeters, correct to 3 significant figures. If you like this series, be sure to comment, like and subscribe to be kept updated on new in-depth videos, and most importantly, share. I mean, what's the point of knowledge if you can't share it, right? And if we can make some people not give up on maths because of these videos, then our job is done. Don't see a topic you need help with? Suggest topics in the comment section. Before you go, if you need extra help with math, science and English and you live in central London in the UK, look no further. We at ONU Learn have opened a tuition centre in the heart of Stratford in East London. And yes, we are as in-depth as these videos when we teach. Check out our site for more details. Thanks again for watching and for learning. Peace.